Hey everyone, how it's going? This is Harish Dalal and welcome to our channel CodeChef. So the problem I will be taking today is counting tuples from recent starters 14 round. The code for which is TUPCOUNT. It is an easy medium problem. The prerequisites is just Euler tangent function. So before we get actually started, here is a reminder to hit the subscribe button if you haven't yet already. Let's get started. So this is the problem definition. You are given an integer n. You have to count the number of distinct tuples a, b, c, d with a, b, c, d lies between 1 to n such that a multiplied by b equals to c multiplied by d. So two tuples say a, b, c, d and e, f, g, h are considered to be different if at least one of the following conditions hold true. If any of the element in a, b, c, d is different from e, f, g, h, then they both are different tuples. For example, if n equals to 3, then these are the 15 tuples that could be made whose a and b is equals to a multiplied by b is equals to c multiplied by d. So here you can see 1, 1, 1 and 1. AB multiplied is 1 and CD is also 1. Similarly, for example, it is 2, 3 and 3, 2. So this part is 6 and this part is also 6. So you have to find out the number of distinct tuples such that ABCD lies between 1 to n. That means we have to find A dot B equals to C dot D. So we can rearrange this equation like A divided by C equals to D divided by B. Hence we have to find the numbers which follows this equation. A divided by C equals to D divides by B, and we can, for proper naming convention, we can use A by B divided by A by B equals to C by D. Those are just naming conventions I am using here. Now we have to find the number of tuples following this. So what is the condition is every A by B can be reduced to irreducible form. For example, if A is 6 and B is 4, this can be reduced to 3 by 2, and this is the most smallest irreducible form for this, because the GCD for 3 and 2 is 1. So we can reduce A by B until GCD of A and B becomes 1. So A by B equals to C by D. Now we have to find the number of fractions for this where A equals to B. So till n, from 1 to n, there will be n such fractions where A is equals to B, which are 1 by 1, 2 by 2, 3 by 3, so on till n by n. So for A should be B in this case, as A is B, so C should also be equals to D to maintain this equality. Hence we have to make the pairs among this group only for A, B and C, D. So let's say if we took A this and B this, we can take C this and D this. Therefore, there are total n square such pairs we can make where A is equals to B. We can make pair from this like this and then this such that. Therefore, there are n square such pairs when A is equals to B. Now let us consider the case when A is greater than or equals to B. So this case and this case is equal because the number of pairs, let's say A is greater than B giving us is x, then the number of pairs A is less than B giving us will also be x. Therefore total pairs will be x plus x minus n square, as we are considering A equals to B in both. and we have to subtract it once a equals to b. So this is the number of pairs when a is equals to b. Therefore we have to subtract it at least once, as we are considering a equals to b pairs in both of the cases. So the final answer, our final answer will be 2 times x minus n square. Now the problem comes is we have to find x, which is the number of pairs when a is greater than b, greater than or equals to b. Now as I said, a by b can be reduced to irreducible form, let's say x and y, where GCD of x, y is equals to 1. Therefore we have to find a by b equals to c by d equals to x by y, where GCD of x by y is equals to 1, where x is greater than or equals to y because a is greater than or equals to b. Now we have to find the number of fractions which is x by y and which lies between 1 to n. The x and y should lie between 1 to n. So the number of pairs, the number of fractions x by y is n by x floor of n by x y. So the number of pairs, the number of fractions x by y is the floor of n by x, because the pairs, then the fractions are x by y, 2 times x by 2 times y, 3 times x by 3 times y. These all fractions gives x by y after being reduced to its irreducible form until n by x times x divided by n by x times y. As we are choosing n by x because this quantity should not be greater than n, hence total fractions are n by x. So the pairs these fractions could form are n by x multiplied by n by x, as each fraction could make a pair with every other fraction. Similarly for this and this, therefore n by x times n by x. But this number of pairs are only for single x and y. There could be, we have to do it for every pairs of x and y, as we already know GCD of x, y is 1. So let's say we fix our x, then what are the possibilities of y we can get? So it is basically the Euler-Quotient function, Euler-Quotient of x, which denotes the number of elements which is less than x and whose GCD with x is 1. Means y belongs to and GCD of x times y is 1. So phi of x tells us number of elements less than or equals to less than x and greater than 1, where GCD of xy is 1. Hence for a singular x there will be phi of x y's we can get. Hence as this number of pairs is just done for single x and y, multiplying it with phi of x, we will be getting these pairs for single x and all the possible y's it can have. For example, if our x is 6, so the possible y's in this case are 1 and 5. There are only 2 because GCD of 6 and 1 is 1 and GCD of 6 and 5 is also 1. Other than that, 2, 3 and 4, this all gives GCD not equals to 1. So it will be 2 times n by 6 multiplied by n by 6. And as it is done for single x and all its y, we have to do it for every x from 1 to n. So the final conclusion is we have to iterate our x from 1 to n and find the phi of that x in 1 to n and multiply it with n by x, multiply by n by x, and this will be our pairs which are forming when a is greater than equals to b. So let's denote this quantity as s, and as I have already mentioned, the final answer will be 2 times s minus n square. As 2 times s is for one s is for this particular condition and another s is for this particular condition, and subtracting n square is because in both the conditions we are considering equal sign, so we have to at least subtract one time because we just have to include it a single time. So we subtract it, so this is for a equals to a and this is for a greater than b and a less than equals to b. So this will be our answer. Now let's jump to the coding part. So I am taking t test cases and creating a vector phi which will be storing the phi from 1 to n, which n is the max n here is 10 power 6. So I am pre-computing my phis, means phis as I have already told. So phi of x is the number of elements before x whose GCD with x is equals to 1. So after pre-computing it, this pre-computation will take n of log n time to compute, and then running a while loop for t test cases. Each test case will have integer n as our input. Now we will store our final answer in long int. As I have told that we have to iterate our x from 1 to n, and for each x we will be multiplying phi of x times n by x multiplied by n by x, as this is the number of pairs for single x and y, and phi of I denotes number of pairs for single x and all of its y's whose GCD x and y as GCD is 1, and adding it to answer. So for every x it will be added to answer, and finally our answer will contain 2 times answer subtracted by n times n. So it will be 2 times a greater than equals to b subtracted by a equals to b, because we are considering 2 times here a equals to b, we have to subtract it at least one time to get a equals to b only one time in our final answer, and finally printing out the final answer. So this is the function I am using to compute my phi values from 1 to n, and the complexity for which is n log n. So this function is written with the help of divisor sum property, where it denotes the phi of 1 plus phi of 2 plus phi of 5 plus phi of 10. These all are the factors of 10 is equals to 10. X is equals to phi of x will be x subtracted by all the factors of x, all the factors of x, phi of all the factors of x excluding x. So the time complexity for which is n log n. You can read about this more on CP Algorithms website. Now let's submit this. And yeah, it's all correct. That's it from my side. Hope you like the content and got the concept. If you are interested in computer programming and want to learn and master data structures and algorithms, make sure to subscribe the channel and press the bell icon. You can also stay updated via our Telegram group. The link is given in the description. So see you in the next one.